All right, Adam. It looks like we can go ahead and get started. So I'd like to say welcome to the webinar this morning. Enertech has invited SWEP to be our presenter for today in a series that we've put together along with the release of our new horizontal ZS and ZT. So then we have the SWEP webinar that we're doing today. And then in a couple weeks, we will have the next session on pumping systems, which I'll get into in just a moment here. But we can go ahead to the next slide if that's all right. So I'll be your host. I'm Kyle Smith with Enertech, and I'm the Inside Sales Manager here. And then we're going to have Adam with SWEP joining us to be our presenter today. And then, so what's happening now is we're going to cover the Braze plate heat exchangers and commercial ground source heat pumps. And this is a webinar that we wanted to cover again as part of our, as a component of our new ZS and ZT product lines. Then next week on December 14th, we'll be welcoming back Jeff Hammond from GeoFlow on maximizing system efficiencies for commercial geothermal systems. And he's going to then incorporate that new ZS, ZT, and SWEP Braze plate heat exchangers into that presentation. Then on a residential approach, we'll be welcoming White Rogers on their new Sensi Wi-Fi thermostat. Just a side note, this webinar will be recorded, as that is a frequently asked question, and we'll be able to provide a link back to this webinar to anyone who attended or was for some reason missed. And then we'll continue on to the presentation here. And one more slide before I forgot here. So if you have any questions, please feel free to ask those in the tab or your work toolbar over on the right-hand side of your screen, and we'll be able to answer those at the end of the session. And there's also a chat feature. And if you have any questions at all, please, like I said, just answer or type those into the questions area. So with that, Adam, I think we can continue on here, and I can hand it over to you.
Thank you very much. And just a first audio check. Can you hear me, Kyle?
Yes, all good.
Perfect. Good. If you hear me, everybody's good. So my name is Adam Dahlquist. I'm working for SWEP. And this webinar will be a brief presentation of the Braze plate heat exchanger technology. Of course, a little bit about SWEP and how the heat pump can benefit from the Braze plate technology and other systems in the HVAC world. Briefly about me, I'm Swedish, so you hear a slight different tone of voice in my accent, and I've been working for SWEP since late 90s, so I've been inside this technology for quite some time. This image shows very directly what is the special thing with the Braze plate heat exchanger. It's a very compact and efficient heat exchanger, and it's made out of plates put together that combines the warm and cold media very close to each other, making it a very efficient heat transfer technology. The special about the Braze plate technology is that there is no frame, there is no supporting equipment around it, so 95% of the material that you put inside the heat exchanger is used for the heat exchange itself, and it's self-contained. So everything what you get here is a very efficient and very light and very compact heat exchanger solution. Then the next step is, okay, so what's so special about the SWEP Braze plate heat exchanger? Because there are other people doing this. What's special about SWEP is that we are the only company in the world that does nothing else than Braze plate heat exchangers. We simulate, develop, make our tools, test them, and make sure that the product we have put on the market is well functioning and very much focused on the market that we are addressing. SWEP itself is a Americanly owned company, part of Dover Corporation, that is part of the Fortune 500. It's Sweden-based, where the main the headquarters is, with around 1,000 people worldwide. We have 6 factories, and we have our own offices in 30 countries. What is most important here, of course, to note is that we have a factory in Tulsa, which is servicing both Enertech and other parts of the HVAC market in North America. We make about 3 million Braze plate heat exchangers every year, and I made a calculation last year that to date we have installed 1.8 million heat exchangers in heat pumps since the late 80s, and we also calculate that we have a field failure rate of 0.01% or 97 ppm over this period. So we try to do one thing and do it good. And now over to how can Enertech and how can you benefit from this. This sketch here shows the heat exchanger system very simplified, where during the cooling operation or the AC operation, the source heat exchanger in the CSCT, which now is a Braze heat exchanger, is working as a condenser. And during winter time or need for heat, the system is working as a heat pump, and the source heat exchanger is working as an evaporator. So the Braze plate heat exchanger has to work both as a very good condenser and a very good evaporator. As condenser, that affects the EER, which is one of the more important parameters when comparing different heat pumps to each other. And when it's working as a heat pump, you want to have a stable operation so that you can work with you can get a good COP regardless of what kind of fluid you have in the source system, if it's water or if it's glycol. And if it's only water, you want to be sure that there is a stable operation and no freezing risk. So that are the things that SWEP has been working with in our development to make sure that we are high efficient and highly reliable. Excuse me. There are other new technologies reaching the market, and Enertech has been very fast in adopting these. And I'm thinking also of the Microchannel heat exchanger on the air side. The CSCT has a Microchannel heat exchanger, further adding to the compactness of the system and also the efficiency. What is special about this one of the things special with the Microchannel is the low internal volume. What you see here is the internal channels of the refrigerant, and they are about the total refrigerant volume of a Microchannel is about half the one of the tube and fin heat exchanger that have been used before. And when you pair that with the legacy technology of a coaxial, you get an imbalance. So the Braze plate heat exchanger with a much smaller internal volume is frankly a better match with this new with the new Microchannel heat exchanger. And the combination of having these two technologies makes the heat pump work in a higher COP, higher ER all over the operating window of the heat pump, since you don't have this refrigerant imbalance inside. That's a little bit, technology. It's inside the nuts and bolts inside the system, but that is something that is you get more than what you are testing according to the AHRI. Another thing that we actually implemented for this system is the Asymmetry. so you can see that SWEP has both symmetric and asymmetric, and we illustrate it by having a smaller one. I will come to that a little bit later on. The value of the asymmetric heat exchanger here is that the water pressure drop is very, very low through the source heat exchanger. We're speaking about 1 to 2 psi, so it's very easy to drive through water here, or glycol, making it I would not recommend to go for a smaller pump, but the pump you have, the standard pump would absolutely be right-sized, and there will be you can even get a higher flow than you anticipated in the beginning. We also touched on the weight and footprint of the system. I know that was one of the key features that Enertech is marketing. That the new CTCS, that is, I don't know if it's 30% or smaller than the old one. I don't know that, but I saw that the smaller size and the lighter size of this new product compared to other ones on the market is something that was remarkable when I looked at it. Another thing we looked into, we started this project a long way away. We started in 2014 to work together for this machine, and what we looked into also was how to make sure that the braze plate work good as an evaporator as well during all the conditions that the heat pump can present. And when the source heat exchanger is working as an evaporator, when the system is heating, one of the problems we have to look up for is maldistribution of refrigerant. So if this is a braze plate heat exchanger looks from the side, if the refrigerant gas and liquid, when it comes in, if there is no good distribution between the different plate channels, the gas can take the fastest route and push the liquid to the side. And what happens then is that only half of the heat exchanger is working as an evaporator, and half is just being a gas cooler, which is very efficient. And another negative thing is that you get a cold spot right here, where so if the evaporation temperature or the water temperature go to risky low areas, this is where you will have the problem first. So SWEP has developed more than 20 different distribution systems based on what application, if it's air conditioning or in this case heat pump, and the refrigerant. And what the result is that we're getting a better distribution of the gas and liquid refrigerant coming in using the whole heat exchanger, or as much as possible as an evaporator, and avoiding the cool spot situation, also further decreasing the risk of freezing during risky operation. I will also touch upon the asymmetry, which is another thing that you will get out of the another benefit, hidden benefit in the CSCT system. The normal efficient braze plate have plates that forms up channels, and in a standard heat exchanger they are the refrigerant and the water channel, they have the same size. SWEP has developed asymmetric tools so we can build asymmetric plates where in the same format, in the same size, we are giving more space to the water channels and less space to the refrigerant channels, because the refrigerant flow is only a fraction of the one of the water. There is much more water flowing through than refrigerant. So the refrigerant needs less space. And by doing so and making sure that the asymmetry is made according to the optimized for this application, we are able to get a double whammy. We are able to get more efficiency and lower water pressure drop. So I would say that the technology inside the CSCT is really top of the line, using microchannel and asymmetric braze plate heat exchangers with a state-of-the-art distribution system. So that there is a I would say I'm pretty proud to be part of this project. The CSCT is in the classical range of between the lower tons up to about 6. So that's the heat exchanger that's called the 26F that we are using here. SWEP has a range that goes from very small capacities up to very large capacities, and with a singular refrigerant circuit or a dual refrigerant circuit, depending on how many compressors you have and what's organized for the system. A little bit further on, looking more widely, what can SWEP do for you? I try to illustrate what SWEP has been, what SWEP worked together with Enertech and what kind of technologies that were implemented for them. If I look outside the heat pump itself and look to the system where the heat pump is installed, in the total HVAC system, I would say that SWEP has solutions that goes from the iPhone 4S size, and I stole this from a colleague, so which is in Europe, so that's why it's in the millimeters. But if you ever seen an iPhone 4, this heat exchanger is very much the same size. And on the other side of the spectrum, we have something that is almost more than 4 feet tall with 6-inch ports. And so this one here is a fraction of a GPM per minute, and this one is 1500 GPM per minute. And they are all built up with the plate technology, where the plates are bonded together by copper filling that is put there during a vacuum furnace process. So once it's put together, there are no wearable parts of the heat exchanger that will consume over the lifetime of the system. If we look on the HVAC system, where we started in '85, we had the maximum capacity we could reach was just one floor of a high-rise, and going forward, where we are now with the modular concept that we have developed, we are present in very large buildings all over the world, in hotels, government buildings, ice rinks, wherever. So there is no real limitation of the size that we are doing. We are even looking into. We are also supplying complete systems, energy transfer systems, where we are able to involve control for cooling and hot water heating, etc. So we are becoming more and more of a heat transfer expert. The applications that we're working in the HVAC industry is both from the header stations for larger district energy systems inside commercial buildings, for example, coupling the heat pump source loop to a ground loop, or to another, coupling the loop of the system to other parts where you need high efficiency and have limited space. To district cooling, where we are connecting a cooling beam to the end user. Since I'm a braze plate kind of guy, I would also like to show a little bit of the braze plate compared to our main competitors on the market, where we are looking on the tubular heat exchanger, which is both a classic shell and tube, but I also categorize the coaxial heat exchanger inside here. And what we see here is that for the same efficiency, we see that the braze plate has 80% lower weight, 80% lower size, less footprint, and everything. On the other plate heat exchanger that is also common in the HVAC industry, the plate and frame, that have the same efficient way of energy transfer as a braze plate, but they have this frame keeping everything together. We see that the typical result with a braze plate is half the weight and 60% lower of the size. Not so much only because of the heat exchanger itself, but the service area that you over a lifetime of a system you will have to open this a few times to replace the gaskets, which you don't have to do with the braze plate. So that is why even though this is pretty efficient heat exchanger, you need to have a lot of space around it to be able to service it over the lifetime, which you don't need to do with the braze plate. And what can else? That there are, as I already mentioned, there are no moving parts or consumable parts of the braze plate, so it remains there and it remains efficient over the lifetime. There is a way to regenerate it in the case of fouling, and I will come to that in the next slide. We have also seen that we have worked with the possibility to expand capacity of braze plates, because you cannot open a braze plate. That's the advantage of it. You cannot open it, but if you cannot open it, you cannot add plates. We have solved that by having a standardized way of adding plate packs to the old one in a way that balances the water flow, and you can add up to 20% of the capacity without any problem. Oops, sorry about that. No, that's right. I was asked before if there is any typical question that arises when it comes to braze plate heat exchangers, and one of them is one of the advantages is the one that you cannot open it, you cannot clean it, and that is the reason why the braze plate heat exchanger needs a very small space, and the gasketed plate heat exchanger needs a large space, because to be able to change the gaskets and to clean the plates, you have to be able to open it. And with the braze plate heat exchanger instead, being a metally locked hermetic pressure vessel, so that it can we can handle up to 650 psi working pressure. They are tested in our facility up to 1000 psi before we ship them. It's possible to use a cleaning in place with a much higher pressure and much higher velocity than the average than the typical gasketed heat exchanger. So we have worked with cleaning in place suppliers in globally, both in Europe, in Asia, and also in US. We have certified CIP companies that have the training and the machinery to be able to clean the braze plate heat exchangers on site with the flows that gives a very high cleaning. I don't find the words. I'm sorry. We are able to clean the heat exchanger with a very high flow, avoiding to having to open up and causing all the leaking and the problem and the downtime that's needed if you have to physically open the heat exchanger. As an end thing here, this was maybe not so much needed for Enertech, as they're an OEM maker. They build their heat pumps in a factory, and so they assemble things there. When it comes to braze plate heat exchangers for the HVAC project market outside on the field, we can also supply connections, heating installations, and support legs and mounting bolts, etc., to make sure it fits where it's needed. So with this, I hope I've been able to guide you through what kind of advantages that Enertech has been utilizing to make their CSCT horizontal heat pump a state-of-the-art machine, and how SWEP participated in this, and how SWEP is working to make the braze plate heat exchanger part of the HVAC industry, to make everybody, most energy efficient and space efficient. And with those words, I am giving the word back to you, dear attendees, to see if there are any things that you want to ask me, to see if I could be a little bit more clear on.
Got it. Thank you, Adam. Very, very informative. I think every time I hear you talk through a presentation, I learn more and more about braze plate heat exchangers, and they're very exciting. And anything that weighs less, it's going to be more efficient and higher in technology. Sounds great to me personally.
Thank you.
So with that, currently we don't have any questions. But I suppose I can ramble on here for a few minutes if anybody wants to type anything in, and let them get that done. If anybody has any questions, though, after today's session, please feel free to give us a call in Inside Sales, rather. We have Brian, Terry, or myself, and that number is 618-664-9010. Or you can email us at insidesales@enertechgeo.com. I'm still not seeing any questions, but I do have one to throw in. And I've become understanding of this, but I think it's still something good for everyone to hear. Adam, so you've heard me ask this, but what about open loops? What should we do with an open loop scenario on a braze plate heat exchanger? And in my opinion, it's just going to be simply put, no. But
well,
I'll let you.
Well, there is always more colors than black and white. It's true, we discussed before. What I do not like, what I would like to say no to, is when there is the popular description is the pump and dump. When you get water from the ground and you don't know what it is, you dig a hole and you take water out of it from one of the higher aquifers, and you use that. The problem with that kind of water is that it can change over the year. It can change over a decade, so you never know what you have. And so with that kind of, if that is what you mean with open loop, I would say don't use the braze plate with the copper. We have solutions where the braze plate heat exchangers is of all stainless brazing technology or nickel brazing technology that is much more resilient against the possible ions that come from the earth. So that is right. That is my no answer. Don't use the standard heat exchanger. Use something more better. And I know that copper nickel coaxials is also used. So it's already considered to be a special application. When the other open loop that I've heard of, or I know of, is the open loop water tower, and that is a different kind of open loop. That is you start with very clean water, but then over time that can also degenerate, and you can have salt buildup, and you can have biological fouling and whatnot in those kind of systems. For those systems, I'm not as afraid. I would say that water management of any open loop with the open cooling tower is of course important. But I know that with the engineering group of Enertech, we discussed the idea of just having a strainer. So there is a strainer in the CSCT system, protecting not only the heat exchanger but also other components that are downstream inside the heat pump. There are quite expensive components in there. Nobody wants to have goo coming at it from a ill-maintained water loop. So when it comes to the cooling tower, just make sure you have water management and don't take out the make sure that the strainer is inside there, and if the strainer is full, clean it and have a look at why is this goo coming to the heat pump. But you can still use the standard braze bed heat exchanger and the standard CSCT. When it comes to the pump and dump or the aquasphere water, I would say if you don't know what's going through the heat exchanger or the heat pump that you acquired, you probably want something that you want something more resilient to sit there and take care of that water coming in, and that would be a copper nickel coaxial or an all stainless braze bed heat exchanger.
Right. Thank you. Yeah, we've on this particular line and our other products currently, we do have that cupro nickel for, as you said, pump and dump systems, and then for and then I liked your explanation, and thank you for the water loop, as we refer to it, cooling tower setup. So, well, Adam, thank you very much for your time today. And if anyone has any questions for Adam or for us, please contact us. And otherwise, be on the lookout for a follow-up email with the recording from today and for more information on next week's session with GeoFlow. Thank you very much, everyone.
Thank you very much.